Vivek, and this Saturday we will do that class. So any of your friend who want to come to that is basically invited, and we will try to give the exam before 30th August because nothing is basically changing. So it's a good opportunity for us to pass the exam in first attempt. Okay, for the lab preparation class. So Saturday, Sunday, 9:30 to 5:30, we will be doing that class here. Okay, guys, let's start the SAN because I'm recording the class, so we can give them recording. Okay. So first thing I would do is I will actually explain you all the terminology and how does it work, etc. from the scratch. And today we will do the theory of FC and FCOE. Okay. So let's put it SAN here, storage area network. Right, and I'm going to compare it to LAN so that you basically don't, and I'll tell you the differences and the similarity because there is a lot of similar stuff here. So here we have the LAN. Local area network, right? So SAN is basically that you have a computer or server, you have a computer here, okay? And you basically have a SAN switch and you have the hard drives, which are known as the JBOD, just bunch of disks. So your server or the computer want to connect to the SAN switch here. This is your SAN switch. Here you need to have a SAN card, which could be basically FC or FCOE. We call it HBA if it is FC. Okay, and if it is FCOE, we call it, guys, what do we call it? Okay, so unified adapter is basically what it is. So, but we need to have the one which actually supports this, right? So it's called CNA. Converged network adapter. These are the terminologies which we need to know. In FC, it's HBA. In FCOE, it's CNA. We have a SAN switch and we have the storage. So this is JBOD, which is basically just a bunch of disks, right? What happens in LAN? We have similar situation where you have a computer which wants to go to the outside world, and there is a switch here, and you basically want to go to the outside world, which could be internet or anything else. You want to access anything. It could be LAN, it could be SAN, etc. Right? So you have a LAN switch, you have a desktop or server, anything, and that has the LAN adapter. Right? So both are quite similar. If you see that it's a LAN switch, it's a SAN switch. Here you have something called VLANs. Here we have something called vSANs, which is exactly same and same number, 124096, 124096. Okay. Here also we have 124096. Right, so we have LAN and SAN. So these are vSAN, these are VLANs. Right here, the protocol that basically is used. So if you may not be directly connected to this, you may have another switch here. There may be another switch here. Similar stuff, you may not have another thing here. You may have another switch. So let's say this is switch SW1 and this is switch number 2. So this is your switch number 1 maybe, and this is switch number 2. Okay, so Here we have different port types and the mechanism and the, you know, the protocol which basically governs these switching and all these mechanisms. The protocol that we have here is known as FC or FCOE. Okay, so depending on what is that we are using right now, let me put it like FC for the time being, and this I'm going to put it what as STP, spanning tree. Right? The purpose of spanning tree is to avoid any kind of loop, at the same time give you loop-free path access to from any source to any destination in a switch environment. Okay. Here, the FC protocol basically in the background utilizes something called ISIS, which is actually a routing. So it's a L2 routing. The protocol is basically FC, but it is the communication of FC happens right using ISIS protocol, which basically forms adjacencies and everything. FC is kind of an encapsulation protocol, which basically have further the SAN card and these guys, they operate on something called SCSI protocol, which is just about two things, which is read and write. Right? So SCSI has a lot of implementation in the hard drive world, which are basically the SCSI hard drive, directly connected SCSI hard drive, or you have SATA, right? We have iSCSI, which is IP-based SCSI. So your LAN adapter is here, your server storage may be here. So that implementation is possible using internet IP address. You can have your storage mapped to your computer. Okay. So Windows has iSCSI initiator and all that. Basically, so if you see that using your desktop, all you have to do is give an IP address of that particular SCSI server, and all of a sudden you will see here in your PC, one more hard drive will be added here. Okay, as simple as that. iSCSI is the simplest stuff that possibly you can see there. Okay. Further, when we go down to this, we have the protocol called FC, which is again a high-level encapsulation of SCSI, and then you have FCOE, which is actually FC over Ethernet. Right, so encapsulating SCSI into FC, FC into FCOE. All these protocols have simple thing, which is read and write, because the computing storage is all about read and write. It's not about the TCP/IP and the window and the sliding windows and the sequence numbers and reliability and all that. There's nothing. It's just this read and write. How do I read and how do I write from a hard drive? This guy wants to boot from SAN. He doesn't have a local hard drive. If you have a SAN card, it will have the PWWN, which is I'm going to explain you in the second part of it, will actually pick it up even before any kind of booting happens. Remember that when you actually boot your computer, right? Yeah, you have to press F2 for the boot menu. Boot menu. So in all the servers, you have these days option of boot from SAN in F2. In your desktop, you may not have that. Remember that. In your desktops, most of the desktops, you may not have this option. But if you are using Intel Xeon-based processors and all that, the motherboards, you basically will have F2 boot menu, which will have the option of boot from SAN. So as soon as the post happens in the motherboard, power on self-test, the next thing that happens is it looks for the booting device. Right? The booting device can be SD card, it can be local hard drive, it can be boot from USB, it could be boot from CD-ROM, it could be boot from something else. Okay, so here the option that you'll have is you'll have to give PWWN of the one of the hard drive assigned to you so that you can boot from there. These days, these technologies are very popular because generally you want to keep your storage in the safe somewhere where you can have multiple RAID levels, which means whatever you do here, this is just an input and output device. This is your storage. They have decoupled that. For years we have been putting hard drives into this, and then hard drives run out of space, especially in today's environment. Right? today's environment is like massive terabytes of data every day for the .com companies and the big corporations, right? Or for even a user, you basically consume 100 GB just like anything, you know, you have learning videos and other things. So this is basically, you know, the basic, the commonality between both the LAN and SAN. So here you have VLANs and here you have vSAN. The vSANs and VLANs routing happens basically on their respective protocols. So here it's STP, and here basically your vSANs will work on FC, which is basically ISIS routing protocol. Okay, there are two type of major ports that you have in switches, right? Which is actually a trunk port. Here, trunk is switch to switch. So if you have a switch to switch, you have a trunk. Here also we have a trunk port. Okay, so here also we have a trunk port. There, to connect the host, which is basically this guy here, right? To connect the host, this port, which is connecting to the switch, is going to be access port. Access port, and this port is basically here. The similar port will be actually known as F port, fabric login port, fabric login port, right? F port or fabric port, you can call it simple. This is trunk port, but it's called E port, expansion port. Right? But it does have trunking, it's TE actually. Trunk expansion, it's TE. Okay? Because you have to carry multiple vSANs over it. Right? Now, like STP, when you connect two switches, you don't have to configure much except who will be the primary, who will be secondary, you know, etc. The root port election and all those elections happen on its own, so you don't have to worry. The switches create a loop-free path. Here also similar stuff. When you connect two switches, you configure trunking between them. ISIS protocol runs in the background. You do not have to issue a single command. All you have to do is just connect two switches, plug in the port of each other into the trunk ports, and just give the command switch port mode E and switch port mode trunk, and that's all. Your ISIS will runs FC, or the routing will run on it, and it will create the best path for you for that particular vSAN. And each vSAN routing is going to be separate routing instance, which is exactly like this guy, separate spanning tree instance, like per VLAN spanning tree, right? So PVST, rapid PVST, or rapid spanning tree, or MST, they all take care of per VLAN or per instance base kind of thing. Here is per vSAN base. Cool, guys. Any confusion, any doubt till here? No. Okay, all good. So this is the most basic comparison out there. Now I will focus completely on this particular portion here. So we'll skip this now. We don't need this. We just will focus here. So there in the LAN, you had the spanning tree. You had root primary and root secondary. Here we have an equivalent guy called principal switch. Okay. Principal switch is one which has the highest priority or the highest PWWN address. Okay, I forgot to compare the MAC address and the PWWN address. So let's go to that first. Okay, so here if you want to communicate, you have a computer or a server or desktop, and you want to communicate to another guy, which is basically, so generally two servers don't communicate to each other in this scenario. Right, in SAN. SAN is always about a guy talking to the hard drive. In LAN, it's two computers talking to each other. Two computers want to communicate to each other, right? Here, it's never about that. SAN is always about that he wants to access a couple of hard drives here. So this is JBOD with multiple hard drives. Okay, And the address which is basically used for this communication is MAC address, sorry, PWWN address, which is equivalent to the MAC address of it. Every adapter, every host which is there, which where you put the SAN card, the HB adapter or FCOE adapter, has two portions of it. A PWWN address, which is basically used for the switching environment, okay, and an NWWN, which is basically a node adapter for his internal purpose. This will never be sent to anybody else, and this has no purpose and no meaning for anybody else. This is actually just for his internal recognition. What is going to be basically working on L2 environment is PWWN. Okay, now PWWN, if you have a host A and host B here, like this computer and these two guys connected on the same switch, you may not require an FCID. Basically, you may require just PWN because you are going to switch it, right? But what happens if you have another switch? In that case, you need to do, right? You can do switching, but the protocol doesn't support switching. So what do? You basically do routing. Okay, and you may have another path to reach to them for redundancy, because you can't take a risk of having one single path and one single switch in the company. So for the backup, you have this switch as well. Okay. So what happens is that you will have something called an FCID, which is equivalent to an IP address. Why? Because we are doing routing. Right? Because FC is all about routing. You are routing. Okay. So FCID is an address which is basically derived from the PWWN address and the domain ID, which I'm going to cover now. Okay. So FCID is what is being routed if you have multi-switch environment, and finally, this PWWN to FCID communication happens on a protocol called DARP. Okay, so this mapping is there, and this mapping is basically called DARP here. Cool. Now, so these switches maintain this DARP. When they have to finally reach to this guy, they will actually be switching the packet using PWWN here. But if they have to go to other switches, how do they reach to them? They need to look at the layer 3 address, because they have to go through routing. Remember that switching between the same switch and routing between the multiple devices. Because same switch as the PWWN doesn't need to really know about anything else. Okay. So FC protocol again is an ISIS protocol, as we were talking about for the routing purpose. FC has two parts. What are the two parts? I told you it has SCSI commands, which is the basic purpose, read and write. And then it has the ISIS in the background, which is for its routing of VSAN. Is any confusion on PWWN and NWWN? There is another thing called SWWN, which is actually like a base MAC address for a switch. Switch worldwide names. Okay, these are unique worldwide names, addresses given to the switch, so that when two switches are comparing to each other, right, one guy who will become the principal switch. Okay, so the highest PWWN will win in this case. The highest priority or the highest SWWN will win in this case. Okay, so it's a little different. It's not the lowest MAC address winning, it's the highest SWWN. So this is fixed address, which is actually already assigned to the switches. Switches have it by default inside it. Okay. So now we can go to the principal switch to see the function of it. So let's say this is a fabric. Now this is another interesting thing, is the word fabric. Fabric, okay? But you look at the protocol is actually Fibre Channel, FC. These are two absolutely different terms, okay? You see that in Nexus 7Ks and 5Ks when I was taking the last class, fabric means the bunch of switches which share same protocol for any communication basically. Fibre Channel is actually a technology which supports various speeds for storage, which is 1, 2, 4, 8, 16, 128 kind of speeds are basically available at this time, Gbps. So it's a protocol basically used for SAN, dedicated only for the purpose of SAN. Okay, and an Indian scientist, I think working for IBM or somebody, he's from Bangalore. He is the CEO of Brocade, basically. He invented this protocol. He has the patents for this protocol. Okay, so the Brocade company and his CEO. So this is a dedicated protocol, basically, which is for the purpose of these particular speeds and other things. Fabric is a concept where when we have Cisco CFS, we basically discussed about Cisco Fabric Services is a protocol, right? Where if you do any kind of configuration on one switch, the configuration can be replicated on all the switches, and you don't have to basically, what do you call it? You don't really have to go to each switch and do this configuration. Cool. So we don't have to go to each individual switch to do the configuration. You can do the configuration at any of the switch, and because it is running, it's a part of fabric. What does fabric mean? So fabric means CFS, CFS and CFSOE. Cisco Fabric Services Protocol, or over Ethernet, or simple Cisco Fabric Services over IP. Okay, over IPv4. There's another one that you have there is CFS over FC. Then you have CFS over IPv6. So these are the couple of CFS implementation that's actually there in the Cisco environment. Note essentially for SAN, it could be used. We have seen in VPC, right? In VPC, what happens? This guy takes care of the things. In FC world, what happens? This guy takes care of the things. This protocol is already running. You can't disable it. It's already there. In LAN switches, in Nexus switches, you can disable it, right? But here, this is already running. Now, there are a lot of CFS you can choose further inside it to, you know, if you, what is that you want to do? So let's say you want to configure times on all the switches so that the time is exactly the same. And your time server may be 1.1.1.1. Okay. So NTP server, the command that has to be there is NTP server, right? And whatever, if you have any stratum levels and all that, you want to configure that. You do not want to go to 15 switches or 20 switches in your network. What do? CFS will take care of it. But CFS does give you an option. You can disable a huge number of services, which is NTP and a lot of other services by using application command, CFS application, and you enable that. There's an option that comes to enable and disable it. If you enable it and then you do the configuration, what will happen? Using the fabric or these protocols, it will be replicated to all of them. Will be replicated to all of them. Now NTP is a layer 3, so you have to enable this, which may not be enabled on an Nexus switch or on an MDS switch, right? Because it's a layer 3 configuration of IP. So you may have to separately enable it so that your NTP can be active and can be sent to everybody else. Guys, any confusion on this, please? Any doubt, any question, any confusion, guys, till now? Okay, so these are a couple of implementations of CFS, and by default, the fabric services FC thing, which when we are going to cover zoning and everything else, those are taken care by CFS over FC. In VPC, Nexus VPC, you have an option to enable or disable it. By default, it is enabled CFS over Ethernet, CFS over E. If you want to do any layer 3 configuration like NTP or call home and other features, you basically have to enable CFS over IPv4. If you want to do NTP, IPv6 NTP, in that case, you have to enable first CFS over IPv6, and then only you can do NTP over NTP IPv6 implementation or anything else that you want to do in IPv6 replication. So Cisco Fabric Services is a replication mechanism. Okay, by default, this is enabled. CFS over FC is enabled. Fabric services over Fibre Channel. This is a communication standard. This is a concept. Okay, it's a concept. Different vendors use different protocols for achieving fabric services. Like Brocade and other vendors, they use their own fabric service protocols. Cisco uses proprietary CFS over CFS protocol. Okay, so that's one thing. The second thing is in this environment, so let me remove some of it. Okay. So one guy is elected as a principal switch here, PS. Okay, one with the highest SWWN. So either the highest priority, by default priorities are same. I think it's 128, and then you have the highest SWWN, which is compared between the switches, exactly like spanning tree. When all the switches come on that particular vSAN, okay, now this is per vSAN basis. It's like your spanning tree route, right? Spanning tree route is per VLAN basis. For VLAN 10, this guy can be root. For VLAN 20, this guy can be root. So exactly here, for vSAN 10, he can be root. The principal switch, sorry, vSAN 20, he can be the principal switch. Okay, what's the purpose of principal switch? Very, very important purpose. Okay, all switches by default dynamically need to have their domain IDs, right? They have to receive the domain ID from the principal switch, and the FC routing happens over domain ID. Happens over domain IDs. Now, these domain IDs are basically quite weird numbers. It could be for this switch, it could be 1011, it could be 2019. This guy has his own dynamic protocol to do all this. He chooses with a random number and assign it to anybody. So if it's vSAN 10. This principal switch is principal switch for vSAN 10. He cannot assign anything to vSAN 20 because he is not the principal switch for vSAN 20. So let's say this is vSAN 10, vSAN 10. Okay, let's do this. So maybe all the switches have vSAN 10, 11, 12, 13. Okay, let's assume that all these switches have these particular, and clean it a little bit. So let's assume that these are like these. So what will happen? How many principal switches will be elected? One for each. 4 principal switches. These 4 principal switches can be anybody. But because this guy has the highest SWWN, what will happen? He will end up becoming principal switch for all four of them. Right? He will become principal switch for all four of them. So, but you can change the priority, like in spanning tree, right? You can change the priority and that guy becomes a root bridge. So here also you change the priority and this guy becomes this. Okay. Now, let's say we have a domain ID for, and I'm taking a case of vSAN 10. Sorry, vSAN 10 here. For vSAN 10, right, this guy is the principal switch and he assigns a random domain ID of this. And maybe you cannot have same domain IDs or there will be conflict and there will be a problem. So the principal switch will disconnect that guy from the network. Okay, let's say these random numbers are basically given by the principal switch to these people. Now the FC routing is going to happen between these people based on this domain ID. The adjacencies will be formed between switches based on this, like you have done in the fabric path, right? Each switch has a switch ID. Here we don't have a switch ID. It's basically a good number of the domain IDs are basically required. Right? Fabric path is a much better protocol. It runs ISIs in the background, can create a single. There are disadvantages to that. The advantage you have here is you have complete segregation of one vSAN routing with other vSAN routing. Okay, so this was what? vSAN 10. Okay, now I'm going to take a different color here and I'll say vSAN 11. Okay, and vSAN 11 may be here. Okay, so this is for vSAN 11. Guys, do you see something interesting here? I have used the same IDs. These are actually used in vSAN 10 also. The black color is vSAN 10, the red is 11. Right, you see that numbers are being used. So numbers can be reused between different vSANs. So this vSAN has absolutely nothing to do with this vSAN. So within that you can rotate it and within that you can basically rotate it, but you cannot have within same vSAN you cannot have two IDs matching. Right, you cannot ever have two IDs matching between inside a vSAN. But in a different vSAN, principal switch can give similar number, same number. Okay, these are completely two different routing instances. vSAN routing of FC is 100% different from this guy, so they will never mix and match. They will never mix and match. They will not mix up with each other. Cool. This is a completely separate routing protocol instance for this guy and a completely separate routing protocol instance for this guy. Okay, so that is possible if you want to, so if the numbers are not conflicting between the switch in the same vSAN, that's absolutely fine. But same numbers can be assigned to different vSAN. Now this vSAN has zero idea about this guy and this guy has zero idea about this guy. Has absolutely no idea about each other. Guys, does it make any sense? I hope you're getting the concept.
Yeah.
Okay, excellent. So that's the purpose of your principal switch. And the FC routing, basically the ISIS routing is going to happen So there will be two separate instances of FC routing, which is going to be one for vSAN 10 and another FC routing is going to be for vSAN 11. It is exactly like you have one spanning tree instance for VLAN 10 and another STP instance you have for VLAN 11. Exactly same. Here in VLAN, if you, these are like a spanning tree, anybody can be, this guy can be root, this guy can be root, you know, that's so anybody can be root. The person with the second best SWWN is a guy in waiting to be the principal switch. Okay, so we don't have a master and a slave kind of concept here, but anybody with the second guy always waits. If this guy goes down, the election happens again, and anybody who has a better SWWN after him will actually become the principal switch. Okay, as I said, as soon as you configure the trunking, the FC protocols, you can go to show FCIE SAN adjacency. Adjacency will be formed between the domain IDs. How does the routing look like? Routing looks like, so when you do show FC route, what it will look like is, it will look like that you want to go to that particular domain ID, maybe 10, let's say 1452. Now I'm talking about the routing of this guy, this particular switch, okay, for vSAN 10. So this is going to look like, for if this guy 1010 switch wants to reach to, sorry, not this one. I think I'm using this one, VLAN vSAN 11. So 1234 wants to reach to 1452. I'm sitting in this particular switch. I'm issuing a command show FC route. And the first thing that will pop up is that I have two links, or whatever links, the number of links I have, maybe this link is to reach to this switch ID. I have a link called FC1 19, okay, and the cost of it, etc. So this is, it's as simple as that. It's like you have done in the fabric path, right? Fabric path was exactly the same. The switch ID and the link through which you can go to it. There's no IP base, anything happening, so don't expect any IP address as the destination. What's the destination? The switch ID is the destination. Sorry, the domain ID is the destination. And domain IDs are assigned per vSAN basis. So these guys will have their own domain IDs and these guys will have their own domain IDs, etc. Right, so domain IDs are assigned per vSAN basis. So what's our destination? Our destinations are domain IDs. Okay, so let's take a scenario here for vSAN 10. And let's say there is a host connected here. So there is a host connected here, okay, and there is a JBOD connected here, and the host wants to access the JBOD. So this is the JBOD. So I have my storage here. This is the storage, and this is the server. Server wants to access the hard drives here. He wants to do boot from SAN. So for certain vSAN, the first thing is they need to be part of the same vSAN, right? So he need to be part of the same vSAN and he need to be part of it. They are not part of the same vSAN. There is definitely something called inter-vSAN routing, which is very, very different from inter-VLAN routing that we used to do. It's completely different. It's like bridging. It's not really the routing, it's the bridging, where you to put two people into the same bridge group and etc. etc. Okay, not part of the scope of what we are doing today. But definitely the word is there. If somebody do ask you, you can say yes. You can use inter-vCAN routing for two people to communicate to each other. And you can also do netting between them. Okay. So let's say this guy wants to communicate to this guy. So how does the communication will happen? His domain ID is probably 102. His domain ID could be 897.123.6. Okay. Now this guy, the first thing he is going to do is he is going to register himself on the F port, right? The first thing that we have to do is we have to do F port. This port where is plugged in, we will go to the switch 102, right? And we will configure it. So basically, let's say this port where it's connected is port number 12. All we have to do is switch port mode F, no shut. That's all. You make it like an access port. Okay, the exactly same stuff here. We'll do switch port mode F, whatever port number, and this guy will be up. Generally in storage, you have FL because they have multiple ports and there's a looping inside it. So there is a new port type called FL, fabric loop. Okay, where you have two or multiple options available so that you can have more bandwidth available. But you have to tell that this is a looped port. Okay. So let's say I have one port, so I'm going to make it switch port mode F, and let's say this is port number 19, so we'll do that. Rest of these links, okay, rest of all the links, the physical links wherever they are connected, we need to have switch port mode E. So let's do this. Maybe on this particular link here, this and this guy, 19 and 19 I have here. So interface FC 19, switch port mode E, and no shut. So let's say they are all connected to 1919. So 1919 and this is 2020, maybe, you know, something like that. So you have to basically go to each switch on the trunk link, which is switch to switch link, and just configure switch port mode E, no shut. As soon as these switches will come up, the first thing that's going to happen is, okay, so I think I made it a little earlier. As soon as these switches come up, there is no domain ID as such right now. Okay, the first thing that happens is they will actually elect a principal switch, because principal switch is a guy who is going to give them the domain IDs, right? Once the domain IDs are there, then only the routing calculation will start, because then only I can calculate the paths available to the next guy. Okay, so let's say everybody agrees that this guy has the lowest, right? This guy has the lowest, highest SWWN. So he goes with the, they all go with this guy as a principal switch for one vSAN, this whole vSAN. And then the switch starts assigning himself and other people a respective domain ID. Okay. Once this domain ID is assigned, and after that, let's say we have this host connected on switch port mode F, the host will try to register himself to this particular switch. It's like an ARP kind of thing where I will give my PWWN address to you so that you can bind it, you can learn it on this particular port. So port number 12, this particular switch 102, he will have an entry on port number FC112 that I have a PWWN bind to it, and this PWWN is maybe AAA or something. Let's say this is the PWWN. Okay. Now this is good enough for him, but how is that he is going to communicate to this guy? And he also has a PWWN, so he is also registering here. Maybe let's go here. His PWWN is basically on port number maybe 20, and it's bound to maybe ZZZ. So now how is that AA, BB, CCC is going to communicate to ZZZ? Okay. So first thing that happens is the routing table built up. The second thing that happens is this process called fabric login FLOG. Okay. So this is a process that's called FLOG, fabric login. All individual devices have to log in into their respective switches so that they can get something called an FCID, which is layer 3 IP address. Okay, but how do you get an FCID? For FCID to be issued, which is equivalent to an IP address, because we are doing routing between these switches, right? So for FCID to be issued, the first and the foremost thing that we have to do is we need to have a domain ID, because FCIDs are generated from the domain ID. Okay, FCIDs are generated from the domain IDs. So this domain ID 102, the FCID is actually going to be a combination of this thing. So it will always start with this, and then you will have AAA, and some area and other concepts are there. So let's say this is FCID generated. Okay, all hosts connected to, all servers connected to this particular switch, their FCIDs are going to start with what? 102. All hosts connected to this guy, their FCIDs are going to start with what? 897. Same thing as this guy's, his FCID is going to be starting with 666. So that's like subnet, let's put it like this. This guy, maybe is a router, has a subnet called 170.0. And this guy has 192.168.1.0. This host, what does this host represent? This host has an IP address 1.1.1.101, right? From this subnet, right? Can this host has any other IP if his gateway is from this subnet? Can you have any other IP if your gateway is this subnet? He can't, right? He needs to be part of the same subnet. If your gateway is on that subnet, you need to be part of the same subnet so that you can be routed. Here also the FCID will have always to be started with and to be issued by the switch ID, because routing is happening based on this. So when this guy, right, this guy wants to do an ARP kind of thing, he wants to go to this guy, right? The switch is actually going to look at this guy's address. He will do an ARP for it, and he will try to reach to his domain ID, which is basically where this, and this acts as the subnet. 666 is basically like 192.168.1.0. Okay. So, and let's put his FCID also, so we can say 606 ZZZ. Let's say that is his FCID. So the routing is going to happen between this guy and through all these paths. He already has the path because everybody has calculated the best path. He has full routing table of everybody. So his routing table has path for him, for these guys, everybody. So he has to elect, is this path better or is this better? So that will be based on the cost. So maybe there is a possibility that this path is 2 Gbps link and 2 Gbps link. And these paths are all 8 Gbps links and 8 Gbps links. So of course, you are going to opt for, and maybe this is your 16 Gbps links, and these are like your 16 Gbps link both sides. So what is going to be the path? The path is going to be this. Why? Because the cost of the more the bandwidth, the less the cost. And the least cost paths are selected. Okay, you may not require a deep understanding of the cost levels of, although if you want to just do that, you do a Google, you will find the cost of each interface type. Fixed cost is basically given. It's like in spanning tree, for 100 Mbps, you're 19 and, other things. So here also similar kind of costs are basically there. You can tweak the cost. You can anytime go and give FC cost on any link, you can change the cost. Okay, so if you want to change the cost of any of the link, you can change the cost. The cost is not this. This is the bandwidth. The cost will be calculated based on the bandwidth. So if you want to give it, less cost, you want to give it, so let's say this is the bandwidth. Maybe the cost is 40, and you want this path to be preferred. So you make the cost here as 10, and in that case, make it 10, make it 10, and maybe this was 40, this was 20 or something, or 40 or 20. So you can tweak the cost anytime. Exactly like spanning tree. So a lot of similarities is exactly like that. Guys, any confusion, any doubt on this? All this is happening on per vSAN basis. This whole routing table represents only one vSAN. Okay, so this is for one vSAN. The other vSAN routing may be completely different from this particular vSAN. In fact, the other vSAN will not have any idea about it. Okay, so this process is called fabric login. The first thing where you get an fcid from the host, right? The individual switch will give you an fcid layer 3 address, and your FLOG process is completed. The further after that, there is another process which is called process login, which is PLOG, which is basically creating a name server kind of database, which is like an ARP entry in your switches, and which has a database of everybody called name servers. Okay, the purpose of that is you can refer the name server anytime to log in or to see any device connected on your network. So if you do, so two commands here. If you do show FLOG database, this will show you all the locally connected devices on switch number 102. If you're issuing the command here, if you issue the command show FLOG database here, it will show you the local database of all the devices, all devices PWWN and fcid here. But if you do on the same switch show FCNS database, name server database, FC name server database, so what will happen? Show FCNS database will show you every single device connected on any switch there in the network. And that's a huge difference. Okay, so what's the difference? The difference is that FCNS database will show you all the devices. So his FLOG is our individual switch database. It's like local ARP of the local switch. Okay, and then you have a global ARP kind of thing of all the switches. So this is like local, you want to check locally who's connected to me, which port, and you want to check show FCNS database of anybody in this whole network, no matter what switch it is. If there is a server here or JBOD here, that information will be actually sent to everybody. When they actually do this routing, they actually look at the name server, they verify the entries there, and then they try to look at the routing to reach to the best path to reach to that guy. It's like ARP, First you use ARP. You find out using ARP, is this guy really there? You try to search him. Then you find out the best paths using the routing table to reach to him. Right? You want to go to internet. First you have to do ARP, right? Then you try to find the best path, and then the translations and all that. And then on internet, what's the name service you have? DNS. Because you have just the IP address, you have just the domain name of it, yahoo.com or google.com, you don't have the IP address. So you have to talk to somebody who gives you an IP address. Okay, so the next process you have is FLOG, which is basically related to the name server. This name server is the most important thing here because you can see any switch directly connected devices basically in this name server. So you will see a single topology of anybody, any end device connected here. All servers and JBODs. In SAN, there are only three things: a server, a JBOD, and the switch. There's no fourth component here. Maybe the fourth component is the SAN adapter. Okay, so show FCNS database is PLOGgy. The last thing is basically known as PR lobby. So the last step you have is PR lobby. So these are three processes. Process login, which is once the path is found, the ARP is done, I know he's there, I know he's reachable, and we have something called zoning, which I'm going to explain now. Once all that is done, you have now the right to log in into it and start reading his hard drive. Okay, this is called login. Okay, process login. So what happens in that? You basically log in into the server, and once you log in, have you seen that in your computer, right? When you try to access your computer, sometime the hard drive takes time and you hear the spinning sound. You may not be using it for some time, or let's say you have an additional hard drive in your desktop or laptop and you try to use the additional hard drive. You try to click on it, it will not come up immediately. It will take some time, and it will also make some noise, right? Because you were actually not logged into it. You have to use certain commands, read and write, and that takes time. If you are in constant process, after that it will not make any sound. If you're constantly getting some data from the hard drive, it may not make that sound. But first time it will actually try to make some kind of noise. Okay, because you are logging into the hard drive. It's very different. See, in LAN, you never log in into somebody. It's like one-on-one, peer-to-peer communication. I'm talking to you, right? I'm communicating with you. I'm not logging inside you, right? I'm asking you the data, you're providing me the data. But in hard drives, it's different. You actually log in into the hard drive, issue your commands, and get your data fetched up from the hard drive. Okay, so let's revise the three-step process. We had the FLOGgy, the basic. You get an FCID here, PLOGgy, and PR log. Process login. FLOGgy, fabric login, port login, process login. Once all that is done, still one major part is pending. No two switches. For the purpose of security, no two people can communicate to each other, even if they are part of the same vSAN. So let's say we have a server here, and I have a JBOD here. So I have switch 1 and switch 2, which is MDS switches, FC switches. And this is my server, which wants to log in into a JBOD. And I'm into vSAN 10. Sorry, vSAN. I'm into vSAN 10. Now, do you think I'll be able to talk to them? The server will be able to talk to JBOD? No. Sorry, this is a spelling mistake here. Right? This third step after the routing is done, all the things are done. There is something called zoning. Because we are dealing with hard drives, it's very important that he has an absolute clarity that out of this 1,000 of hard drives, which hard drive he should be able to log in. Okay, it has to be secure, because if he by chance detects a wrong hard drive, which was actually assigned to some other server here, okay, let's say this is server A and this is server B. So if this guy by mistake, server A guy, picks up server B's hard drive, because there is no security mechanism, he's going to maybe format. He will do something wrong with the hard drive of somebody else. Maybe he's using a different operating system type. He may be using Linux. This guy is using Windows. But because his hard drive is visible to him, he thought it's his hard drive. He issued a format command to his hard drive. Okay. So let me put the hard drive PWWN is for this. And the second one for server B is, let's say, BBB. So he originally wanted to have an access to AAA, this guy, and this guy wanted to have for BBB. Now, if there is no security mechanism, we will get messed up. So there are two security mechanisms we have. One is the JBOD provider, the NetApp or EMCs and all that. That's called LUN. LUN mapping. Okay, which is basically called, these hard drives are called, the logical hard drives are called logical units. Right? So LUN mapping is done by the JBOD provider, whatever company is you're buying the JBOD, Hitachi or EMC or NetApp or any other company. Okay, so these guys will do the LUN mapping. And so what is LUN mapping? Is a process of putting PWWN of this guy. So let's say this guy is a PWWN. Let me use a different color. His PWWN is AAA, BBB, CCC. And he needs to access maybe AAA, CCC, CCC. Okay, so who is going to do that? This guy, basically, these guys can actually do that. They will map these two people. So in one zone, let's say I have this. Okay, you guys want to take 5-minute break? Okay, guys, let's take a break. Okay, so let's take a 5-minute break. We'll be back at 10:10. This is 10:04 right now, 6-minute break. Guys, everybody back? Guys, are you there? Can we start?
Yeah, we can start, Vikas.
Okay, excellent. So I was explaining about the LUN mapping, right? The purpose of LUN mapping basically is that you can, from the provider side, you do the LUN mapping. Cisco does do additional verification and from the switch admin perspective, we can do another thing called zoning. So zoning is exactly the same as LUN mapping, so let me give you an example of this LUN mapping, that what will be there, let's say this particular LUN, so it is going to be, maybe give it a name, maybe LUN 10 or something, and in this there will be two entries, PWWN AAA bb.ccc can access, another PWWN who can talk to each other is ccc.ccc. So it's as simple as that, no complexity. You go to EMC or NetApp and all that, create a LUN, and this is your LUN. Okay, which basically tells that if this is my hard drive, this is my hard drive, if only this guy comes, I will allow my hard drive, or I will only allow these two PWWNs to talk to each other, because only he has the authority to access it. Okay, only he has the authority to access it. If it's a VMware kind of environment where you have shared storage, maybe I want to add another guy here, I can definitely add this guy also here. That means that this hard drive will be now shared between these two servers. Okay, so there is a possibility there. The second thing is from Cisco switch, so we don't have to do LUN masking, LUN mapping and LUN masking we call it. We don't have to do that. Okay, so that's another word basically I forgot. LUN masking or LUN mapping. What we do on the Cisco switches is this, we do zoning. What we do in the zoning is basically you create a zone name, whatever name you want to create, vSAN 10, and all you have to do is member PWWN A and member PWWN, whatever the hard drive, HDDA or whatever name you want to give it to, maybe A something. Okay, so maybe this guy, this MAC address, this PWWN and this PWWN. Okay, so this is a lengthy process. Then we have a zone set and all that. But this is just to give you a brief idea that once you create it and you distribute this zone name, and that will be sent to everybody in the fabric. So if you have 50 switches in your network, in vSAN 10, everybody will receive this mapping. Tomorrow you unplug your server from here to this particular port and plug it here. You don't need to do anything because it's not a port-based mapping. You see that? It's a communication mapping between one PWWN to another PWWN, which means this server can communicate to this hard drive. If I have another thing here, maybe server B and his MAC address, sorry, PWWN is BBB, and maybe this guy here is DDD. So in that case, there will be another zone. Zone name, maybe server underscore B, right? For vSAN, whatever. If you have vSAN 10 or 11 or whatever vSAN it is. And in that case, it is going to be member PWN. Going to be BBB, and member PWWN is going to be DDD. You can also put FCIDs, but FCIDs may change with the, if you're moving from here and his domain ID is 102 and his is 104, in that case, if you ever move from here, your FCID will change. So if your mapping is there, that's a bad idea. Always use PWWN, because your adapter PWWN is a burned in address. That's never going to change. Okay, so the recommended practice is to always use the PWWN addresses, because those are BIA, burned in addresses. So they will never change. So this port, if ever this guy goes from here to here, your mapping is always intact. Sorry, this guy. The second thing is zoning is distributed using CFS, Cisco Fabric Services, in all throughout the fabric for that VLAN, vSAN, sorry, whatever vSAN it belongs to. Okay, guys, any question on the zoning or the LUN masking? Any doubt, any question in anything else? Okay, so these zones that we create, they will not get distributed using CFS on their own. We have to create a next thing called zone set. Okay, so let's say I create a zone set name, maybe SS for vSAN 10. And my member zone is what? My member zone is, one is Vikas, and my member zone is, another one is server_B. Exit from here and you say zone distribute, sorry, zone set distribute name SS vSAN. As soon as this command is issued, you will go to all the switches in your network and you will see that this information is now present in all the switches in the network. They all have it. Okay, so they will all allow them to communicate. Tomorrow the host moves anywhere, doesn't matter. The JBOD moves anywhere, doesn't matter. You will allow them to communicate. These are like ACLs. These are like ACL entries. So basically you are pushing these entries in the control plane rather than on the data plane, telling everybody that these two people are allowed to talk to each other and these two people are allowed to talk to each other. Now these two people are not allowed to talk to each other. So this server A cannot ever access hard drive of B. What if you want to add it tomorrow? So what you do, you can do that. You can add here member PWWN A. So now what are you allowing? For single hard drive, you have two servers. Not a recommended practice, but you can do it. Okay, and then again, each time you make any change to the zoning, what do? Distribute it again. Redistribute the information. You have to issue this command. Any new change made to the zones, any changes made it to the zones will not be distributed to all the switches, will stay local if you do not issue this command. Okay, so guys, any question, any doubt on this? So I'm done for today, guys. I'll do it tomorrow again because I don't have access to devices. Otherwise, I could have shown you practical. Tomorrow morning, I'll have all the rack ready, and I'll show you the practicals of these, and we'll cover more theory. There is a huge amount of theory. The commands are less. Most of the things happen on their own, except zoning. There's nothing complex there.
Okay, sure, Vikas. Thank you.
All right, so I'll see you guys tomorrow. You have a great day.
Thank you.
Thanks.
Thank you.
Bye.